Okay, for the chapter 10, so you should have ready to print your notes. Okay, so this is a lecture notes, chi-square test. This test is actually a summary to test about a qualitative data set. Okay, so in the lecture 1, you know what is qualitative data. So say for example, if we would like to test about the relationship between the sex, okay, while you notice that male and female cannot be explained by using numbers, and then maybe say like habit of smoking, so which is smokers or non-smokers, so which is a qualitative data set. And then the next one, maybe there are some testing where the education level, university, secondary schools, primary school, should be qualitative data set which you cannot express in numbers. And then if you would like to test whether education level has any relationship with the religions, Christians, Catholic, Buddhism, you also can use the chi-square testing. And then this is 2 or 3 examples, and then the third example is simply the same. So now you take a look for testing. As I said on the announcement of the Moodle, so you can see the test is in fact the observed frequencies. Okay, so which you can actually write down the observed frequencies is in fact about the fact. Okay, so you are going to see whether there is any difference between the fact, okay, while the observed frequencies and expected frequencies. Okay, so the general concept is that this expected frequency should be calculated by yourself. Okay, so observed frequency is a fact which will be given in the questions. And then for the expected frequencies is calculated, and then which I announced in the announcement is that it should be based on the assumption that the H0 is true. Okay, so H0 is true. So what is the meaning for it is that we would like to know what is the H0 and H1 first. Okay, in the chi-square testing, the H0 should be there is no difference. Okay, remember no difference, no relationship should be placed in the null hypothesis H0. No difference or relationship between the two data sets. Okay, so between the two data sets. So while the H1 should be there is difference or relationship between the two data. Okay, so take a look for example 1. So you see consider the following observed frequencies in which you can see there are 2,650 students in a school, and you're going to test whether the ratio of boys and girls are the same. So for the H1 and H0, how the test is that, well, this is a table. In fact, this is the observed frequencies, the OI, right? Okay, and then the next is, according to what I had said just now, H0 should be something that is no difference, right? So in the H0, no difference between the ratio of boys and girls, right? Okay, so if you really don't have any difference between race of boys and girls, so you must have 1,325 boys and 1,325 girls, so half of them. So this number is in fact coming from 2650 times 0.5, while this one is also the same. Half of the total is boys, half of the total numbers is girls. And then what you need to do is that after we have calculated, this is calculated by ourselves. Okay, calculated by us, and then you should use the following chi-square test statistics to do the following. So first of all, the OI means the observed, and then the EI stands for the expected, right? Okay, so while this one is the expected as well. So following the steps, so you should have using the chi-square test statistics for the boys, the fact OI is 1600, which is actually coming from the page number 1 in here. So you pick this up and then minus the expected frequencies of the boys, so which is you have 1600 minus 1325 and then bracket square and divided by EI, right? So you need to divide by 1325. So this number is in fact talking about the boys groups. And then the other one is the girls groups as well. So you have a girls group. So if I have the boys difference, if I have a girls difference, so I simply calculate and I got the test statistics 114.1509. This test is in fact is a positive skill test. The x-axis is the chi-square. Okay, the x-axis is a chi-square, and then you have to understand that if I have a lot of difference, which means that if I have a lot of difference, so that means the H0 should be wrong, because we are talking about the fact and what I assume the EI should be no difference with the OI, right? So that's why if OI very close to the EI, that means the H0 is true. Okay, and then in fact that if the chi-square statistics close to 0. Okay, if a chi-square tested statistics very close to 0, so you should have the null hypothesis should be true. So if the OI, so which is far away from 0, so that means the null hypothesis is false, because our assumptions about the EI is wrong. Okay, so if you got a chi-square statistics which is very far away from 0, okay, OI is far away from EI, okay, and then chi-square statistics is far away from 0, so that means we have a null hypothesis is false. Okay, so simply speaking, so you can take a look for a diagram. If I got a large numbers of chi-square, so the null hypothesis is rejected in this area, while the null hypothesis is true. Okay, so 114.15 is very close to 0 or far away from 0, so you have to ask one number which is called the degree of freedom. And in this case, the degree of freedom is just a table which you got number of category minus 1. How many categories do you have? So you have boy, girls, which means 2. Okay, so therefore the degree of freedom in this case should be 2 minus 1, so which is 1. And the level of significance in these questions, as you can see here, is like 1%. So we don't have any two-tailed test, so you should take out your chi-square test, and then degree of freedom is 1, which you got degree of freedom is 1 here. And then you can see that the significance level is 1%. Okay, so that's why you can see the answer is 6.635 in here. Okay, 6.635, so you can take here 1%, degree of freedom is 1, so that's why critical value 6.635, and then you need to write in here. So while the 114, okay, so while the 114.15 is actually a very large number, so that's why the null hypothesis should be rejected, right? Okay, so therefore the conclusion is, since the null hypothesis is rejected, so therefore the H1, there is difference between the ratio of boys and girls. Remember, H0 no difference, H1 should be difference, so therefore last but not least we have the following answers. There is difference between the proportion of boys and girls, so this is the example number 1.